In the next couple of videos, I want to show you another method that you can employ, the critical region method. And there are some exam papers that have specifically asked you to find the critical region. So although the previous method can be quicker than this one you do need to know as well. Okay, so in a coffee shop, the probability of a customer asking for an espresso coffee is 0.4. During one particular day, in a random sample of 12 customers, 2 asked for an espresso coffee. Test at the 10% significance level whether the proportion of espresso coffees ordered that day is unusually low. Okay, so we start off by saying what P is going to be. So let P be the probability of a customer ordering an espresso. Okay, so that's our first line. We then set up the null hypothesis, H0. So the null hypothesis would set the probability to still be at 0.4, the devil's advocate position. And the alternative hypothesis, because we're saying, well, wondering whether that 2 out of the 12 is unusually low, we're wondering whether the probability is less than 0.4. So we then assume that H0 is true, and we set X to be binomially distributed with n, number of trials 12, because that was the size of the random sample, and the probability of P 0.4. So up until now, everything has been exactly the same as it was, okay, with the other method. It is here where things slightly change. So at this point we get our tables, okay, and we go to n is 12 and a probability of 0.4. And what I want to do is I want to look down the 0.4 column until I hit this 10% significance level. So what I find is that we've got the probability of x being less than or equal to 2. This is what I would write down. Probability of x being less than or equal to 2 is equal to 0.0834. And the probability of x being less than or equal to 3 is 0.2253. So you see what we're doing is we're getting this crossover point of the 10%. So we've got one that is less than 10% and one that is greater than 10%. Okay? So what that's doing is it's telling us that 2 or less is our critical region. It is the values of x that are within that boundary, okay, that 10% boundary significance level. 3 is not, because 3 gives us a probability that is over the significance level, okay? So the critical region, so x is equal to 0, 1 and 2. That's our critical region. Okay? Now what we do, once we have our critical region, is we compare it with how many actually asked for an espresso coffee this day. So we have 2. Now we find that 2 is inside the critical region. So x is 2 is in the critical region. And what that means is that we now have evidence to suggest that the proportion of espresso coffees ordered that day is unusually low. Okay, so we can reject H0. Okay, so there is evidence to suggest that the number of espresso coffees, I have to finish it up here, ordered that day was unusually low. Okay, so the process is different really in this section here. This 4 lines that we have here, where we've got to find that crossover region within the tables in order to identify what the critical region is. And then we compare what we have seen in our sample, so 2 in this case, whether that was in the critical region or not. Okay? And then it finishes off as it usually would.